When educational teams sit down to collaborate, the effectiveness of their entire meeting hinges on how they answer one question: what must students actually learn? A common friction point in these meetings is the activity trap, a phenomenon where the focus of planning shifts from the internal acquisition of a skill to the external completion of a task. Consider a standard activity target. A curriculum map might state, students will complete a set of fraction comparison problems. Compare that to a mastery target for the exact same lesson. Students will justify their fraction comparison using visual models. The first target measures behavioral compliance. If a student finishes the worksheet but gets half the answers wrong, the teacher knows the task was performed but remains uncertain about what the student actually absorbed. The second target operates as a diagnostic tool. By requiring both a justification and a visual model, it forces the student to externalize their cognitive process. This distinction is critical. Defining learning as an activity leads to blunt, generalized reteaching, whereas defining it as a skill enables precision intervention. We can measure the exact impact of this precision. A systematic review of 132 distinct studies analyzed how specific instructional choices alter classroom outcomes. Researchers isolated multiple teaching factors, from classroom environment to time management, to track their direct influence on cognitive, affective, and psychomotor achievement. This bar chart illustrates the results. Notice the variable labeled structuring, the practice of providing clear, explicitly defined learning objectives. It carries an effect size of 0.50, placing it among the highest leverage actions an educator can take. In controlled studies, courses utilizing explicitly aligned outcomes generate a 12% average increase in student performance on assessments. The data also reveals a scaling effect based on the complexity of the material. At the university level, where cognitive demands are highest, the impact of precise structuring is nearly triple that seen in primary education. Writing precise mastery targets serves a strict cognitive function. It is an empirically proven mechanism that drives measurable academic achievement. The failure of most curriculum mapping stems from a single structural flaw, relying on verbs that describe internal states rather than observable actions. To build a functional target, educators must eliminate 4 vague verbs from their professional vocabulary: understand, learn, know, and explore. Psychologist John Sweller's cognitive load theory explains exactly why these words impede the learning process. Sweller identified a bottleneck in working memory called extraneous cognitive load. This is mental effort wasted on non-essential tasks, confusing instructions, or poorly defined expectations. When a teacher tells a class to understand the theme, the student must spend their limited working memory deciphering what the teacher actually expects them to do to prove that understanding. Precise targets strip away this ambiguity. They free up cognitive capacity, allowing the student to dedicate their mental effort to processing the actual material. You cannot observe an internal state. Assuming a student possesses knowledge based on compliance yields 0 actionable data for the instructor and overloads the learner. The solution to vague objectives requires applying the principle of constructive alignment. Constructive alignment demands that the stated learning outcome must explicitly and identically match the assessment task the student will perform. This structural equation is the mastery target template. It forces educators to build alignment directly into the lesson plan. The first variable isolates a specific demonstration verb, dictating the exact physical or intellectual action the student will execute. The second variable specifies the exact type of evidence or artifact the student must produce. The third variable explicitly states the underlying standard this action proves. Applied to a mathematical standard, the template produces this. Students will justify their solution strategy using labeled visual models to show mathematical reasoning clarity. This structure forces educators to visualize the final student artifact and determine exactly how it will be measured before they ever design the instruction. Writing a statement in a template is only the beginning. To ensure a target generates actionable data, it must survive a strict 4-point calibration protocol. Step 1, observable. The target must result in direct, visible evidence of the skill in the student's work. Step 2, measurable. The target must be specific enough that multiple teachers across different classrooms will grade it with total consistency. Step 3, misconception revealing. The target must be engineered so that an incorrect answer exposes the specific error pattern in the student's logic. This third filter is the dividing line between a grading rubric that penalizes mistakes and a diagnostic tool that identifies gaps. Step 4. Scalable. The target must allow educators to classify the artifact as below, on trend, or advanced without resorting to subjective guessing. The rule is absolute. If a proposed target fails even one of these 4 criteria, the collaborative team must send it back for revision. This calibration guarantees that when teams analyze student data, they are looking at identical, actionable evidence rather than debating their subjective impressions. Once successfully deployed in schools, these precision targets create an immediate operational feedback loop for instructional coaches and teachers. Because the target is designed to be misconception revealing, it automatically flags exact cognitive gaps. The team no longer wastes time discussing if a student struggled. The artifact dictates precisely where the intervention must occur. This clarity also impacts the learner's psychology. Data confirms but explicitly aligned outcomes significantly reduce student assessment anxiety by removing the mystery of the grading process. When expectations are this transparent, students gain a literal reference point for their own progress. By comparing their current work to the specific criteria in the target, they can begin to monitor their own learning and direct their own study efforts. This direct line of sight fosters metacognitive awareness. Students identify their knowledge gaps, adjust strategies independently because they know the goal. The objective of a 60-minute training module is not administrative compliance. It is an overhaul of how the team analyzes evidence and coordinates its response to student needs. Precision targets ensure that a student's demonstration of mastery is evaluated with the exact same rigor, regardless of the classroom they sit in or the teacher instructing them. By stripping away vague activity and insisting on observable mastery, an educational institution builds a shared, objective language of achievement that scales across every grade level and discipline.